learners, welcome back to my channel Maths Made Easy with AB. So today we will be studying about monotonic function. We are continuing our series with function introduction to calculus. If you have not seen my previous videos, I'll request you to see those and then get back to this video. So let's see what does monotonic function actually mean. So basically the word monotonic, we indicate the monotonous behavior, that is the sense of ascending or descending. So basically there are two types of monotonic function. There are two basic types of monotonic function. One is increasing function. One is increasing function. I'll tell you what increasing and decreasing function mean in this video. So one is increasing function and the second one is obviously decreasing function. The second one is decreasing function. Right students, so one is increasing, another one is decreasing function. I'll tell you how they look like. So actually increasing function is something where the function value keeps on increasing, the output, the y value, y axis, x axis, the y value will keep on increasing for increasing x, right? Say for example, you are at x1. If you go to x2, the output should be greater than what you are getting for x1, which means what? That if x2 is greater than x1 students, if x2 is greater than x1, then f of x2, that is the value of f of x2 should be greater than value of f of x1. x2 is greater than x1, which means you are going this side, then this value should also go up. So that is the basic meaning of increasing function, right? Decreasing will just be the opposite. What will decreasing indicate you? This was increasing function. Decreasing will be similarly like this. So see over here, x1, this is x2, you are going this side, so the value of what? F of x1 is decreasing, it is going down. You are increasing x1, so basically x2 is greater than x1, but here f of x1 is greater than f of x2. So this is the basic definition of decreasing function. So with increasing x, the value of y, that is f of x1, f of x2 will decrease. That is known as decreasing function, students. I think this one was very clear. If you are seeing my series of functions, I think these all won't be very much troublesome to you all. If you have not seen my series, do watch. So now students, increasing functions are again of two types. So increasing functions are again of two types. So first type is increasing function. So increasing are of two types. One is strictly increasing function. One is strictly increasing, another is non-decreasing, students. I'll tell you in details what each of these mean. So increasing function, monotonic function is divided into two parts. One is increasing function, another is decreasing function. Increasing function has two parts. One is strictly increasing function and another is non-decreasing function. Right students? So let us see what is the decreasing function of two types. So decreasing function, strictly decreasing functions are of two types. So one is strictly decreasing, another is non-increasing. So students, this is the basically the classification of monotonic function. Monotonic function is two part, increasing function, decreasing function. Increasing is two parts, strictly increasing, non-decreasing, strictly decreasing and non-increasing are the two classifications of decreasing functions. Now let us see what each of these mean. So we are in the series, in the chapter of monotonic functions, students. If you are liking my videos, do subscribe to our channel. So we will be coming up with more such interesting problems. So let's see first strictly increasing function. Yeah. So by strictly increasing, I'll simply draw the graph and show it to you. So strictly increasing means like this. This is x-axis, this is y-axis. Over here what you will get is, so let me tell you another thing. So if you have read this or not, or maybe this is the first time you are moving into calculus. So let me give you some of the basics of calculus. So basically so let's erase this part. So if you see now, this is a curve, say for example, and what is f dash x? So this is a curve y is equal to fx. Say for example, students, this is for somebody who don't know, who are seeing this for the first time, strictly increasing. So y is equal to fx. Y, what f dash x means? F dash x means f dash is a differentiation of fx, the function fx. Differentiation of fx. If you don't know, students, don't worry, just listen over here. In the next videos it will be clarified. If somebody knows, then I think this will be very clear to you all. So what is y is equal to fx? So y is equal to fx is the function, the graph that you are seeing. Y is equal to f dash x. What is the meaning, the graphical meaning of f dash x? So the graphical meaning of f dash x is a tangent to this graph, a tangent to this graph. So basically, if f dash x1 means the tangent to this graph at point x1, the tangent to this graph, so basically if you touch this graph at this point, to this graph at x1. So the tangent to this graph at x1, basically f dash x is the slope. So you can see f dash x is what? Positive. The slope will be what? Positive. Right, students? So if you know, so this is how we find it. So f dash x means this tangent to this graph. If you want to find out at which point, then f dash x is equal to 0 and all. So we will be seeing it in the application chapter. I just gave you a basic of this part. Okay, so if a function is strictly increasing, students, so a function is strictly increasing, you have to remember, so if a function is strictly increasing, you all know that, say, this is x1, this is x2. If you increase the value of x, the value of y will increase. So basically for x1 you get the value of y1, and for x2 you are getting y2, right? Y1 is nothing but f of x1. I am removing this f dash x now. I am removing this f dash x. So basically f of x1 is nothing but y1, f of x2 is nothing but y2. So basically the values of y. So students, understand this very carefully. If x1, so you are moving from x1 to x2, then y1 should move towards y2 at a greater value. If the value reduces, it will become strictly decreasing function. For strictly increasing function, the value should strictly increase. And students, in this case, if I draw a tangent, you are seeing what? F dash x should be greater than 0. F dash x should be greater than 0. So this is the condition. This is the condition which a function y is equal to fx has to satisfy. This is the function, this is the condition that the function has to satisfy to become a strictly increasing function, students. So basically the slope of this line is positive. You have to keep this in mind. Strictly increase. So slope of this line is how much? Slope of this line is positive. Slope of a line parallel to x-axis, students, tan 0 is what? 0. Slope is 0. So this, you have to keep this in mind. Here this line, this function has always to be what? This function has always, it has to be giving you a positive slope, and f dash x is greater than 0. So if let's remove all those positive slope, negative slope, f dash x. Just simply remember, for a strictly increasing function y is equal to fx, for this graph to be strictly increasing, it has to satisfy only one condition, that is f dash x is greater than 0. Students, f dash x may also be 0, but only at finite number of points and not in an interval. You may write it down. F dash x may also be 0, but only at finite points, not in an interval, So this was about strictly increasing function, right? Let us now see what I meant by non-decreasing function. Students, let us now see what I meant by non-decreasing function. So let us see about non-decreasing function. Let us see what does a non-decreasing function mean. Students, a non-decreasing is very simple. So here at sometimes you will get f dash x is equal to 0. So a line moving parallel to x-axis. So just like this, say for example some graph is moving and then suddenly it is like this and then it started moving like this. Right, students? So like this, a function won't be differentiable if it has a point. So let's make it like this. Say for example like this, a graph. So you cannot call it a decreasing graph, right, students? Say for here, over here, say for example I have x1 and over here I have x2. So f of x1 is equal to f of x2, right over here. If I draw a tangent, students, it will become what? Parallel to x-axis, and then it will give a positive, it will give a zero slope. So here, students, you have to remember, for a function, this has to be greater than equal to 0. So for a function to be non-decreasing, the condition that it has to maintain, for a function y is equal to fx to be a non-decreasing function, which means it is increasing, at times it is constant. Here it is constant, right? Here it is strictly increasing. Constant plus strictly increasing means what? It's a non-decreasing function. I think I have made this very much clear to you all. So f dash x is greater than equal to 0. F dash x is greater than equal to 0 for a non-decreasing function, students. I think this is very much clear to you all. Right, let us now understand the next part. Which is strictly decreasing. So now I won't draw the graph too much. I am doing it shorter. So strictly decreasing, if you draw, say for example, a curve, let's not draw it in this way. Let's draw the curve like this. So strictly decreasing, students, this is x-axis, this is y-axis. I just told you this is a strictly decreasing graph because, say for example, this point is x1 and this point is x2. This point is x1, this point x. You are moving from x1 to x2. So x2 is greater than x1, students. You are moving from x1 to x2 means you are moving at a higher value. Now, what is happening to the corresponding value at y-axis? So you were at f of x1. Now you have moved to f of x2. Which value is more? F of x1 is more than f of x2, which means the value of y is decreasing. This denotes a decreasing function. Students. I think this is very clear to you all with the graphical view I am telling you. So you are moving from here till here and this one is moving from up to down. The value keeps on decreasing. And students, what will be f dash x? If I draw a tangent at any point, so the slope will be what? Negative. The slope will be negative, right? More than 90 degree, tan theta, right, students? So understand this. What will happen over here is the slope being negative. So f dash x will be less than 0. So for a function y is equal to fx to be strictly decreasing, the condition that it has to satisfy is f dash x is less than 0. Don't worry, students, we will deal more when we go to application of derivative chapter. You can also skip this chapter if you think you have not gone through derivative right now, and you can come back once you are done with derivatives. You know what derivatives are, how to differentiate functions. You can come back, revisit this, so that this is actually the application. But since we are in functions, it was compulsory that we should have covered this in this chapter. If you are a repeater, means you have already appeared for class 11, 12, I think this chapter should make sense to you all. Right, students? So similarly, students, this is the function for strictly decreasing. This was for strictly decreasing. Now for non-increasing function, students. Now for non-increasing, so it will be what? F dash x is less than 0, less than equal to 0. For a non-increasing function, the criteria that has to be fulfilled is f dash x is less than equal to 0. It is the same concept, students. I'll just show it to you graphically. For a non-decreasing means at times the function will become constant. Say for example, a graph was coming like this and it has become constant and like this. So here for some point it was constant and then it came like this. So from x1 till x2, the graph is what? Constant. So it is neither increasing nor decreasing. Hence we are saying it is non-increasing, right? We cannot say it is strictly decreasing because here the function is constant. So it's a combination of constant and strictly decreasing. It's a constant plus strictly decreasing will give you a non-increasing function, and the criteria over here is f dash x is what, students? Less than equal to 0. So these are the 4 important concepts that you have to keep in mind for solving any numericals that comes regarding increasing, decreasing or monotonic function. I'll quickly show you with the help of an example how to solve problems when it comes to monotonic function. Before that, let me teach you a very easy since many of you might not be knowing differentiation at this stage of my video, watching a video if you are already in the series. So basically, say for example, if fx is x to the power of n, x to the power of n means x to the power of 4, x to the power of 5, anything, yeah. So if fx is x to the power of n, f dash x means the differentiation of the function fx, which also means signifies graphically tangent. F dash x means the formula is n will come in the front, x will remain n minus 1. So this is the formula. The coefficient will reduce by 1 unit. So for example, if fx is x to the power of 5, so I am giving you an example. This is an example. So if fx is x to the power of 5, f dash x will be 5 will come in the front, x to the power of 5 minus 1. I have simply applied this formula here. So this is 5 into x to the power of 4. That's it, students. So this is the basic formula of differentiation. We will be using this formula in the next problem. So that is why I just gave you the brief. So this is differentiation. So we will be dealing with differentiation after we have completed the entire series on functions. So basically the next videos that you will be on composite functions, and there will be what is the period of a function, etc. So there are many things remaining inside functions to be done. Then we will go through limits, and then finally we will enter differentiation. Okay, so students, so let us now see, having said this, the next question that we need to solve is, so find the interval. So you can write down the question, find the interval of increase or decrease of the function fx. Find the interval of increase or decrease of the function fx is equal to 2x cube plus 3x square minus 12x plus 1. Students, so this is the function. You will have to find the interval where the function increases and where the function decreases. So this is very simple, students. If you are asked a question, you are given a function and they are asking you what is the interval where they are increasing or decreasing, simply f dash x you will have to find. You will have to find f dash x. So what is f dash x? F dash x is this, right? 3 will come in front, 6x squared. Just before this I taught you the formula, plus this will be 6x and this will be minus 12. That's it. X 0, so x to the power of 1, so 1x, and it will completely vanish. And differentiation of a constant is 0. Differentiation of a constant number is 0 because it has what? It has nothing, means it has into x to the power of 0, 0 will come in front and this entire part will vanish. So differentiation of a constant is 0. So this is the function, students, f dash x. Now what you will have to do is, for this function to find the interval in this function is increasing, you will have to do what? You will have to apply the condition f dash x is greater than 0, students. To know the function is increasing, you will have to put f dash x is equal to greater than 0. So basically 6x square plus 6x minus 12 greater than 0. So this will give you, removing 6 plus x minus 2 greater than 0. So this is what you will get if f dash x is greater than 0. Students, you already know wavy curve method. So I am going to, if you have not seen my series video on wavy curve, there are 2 videos, very important, very critical. I have already said that if you are seeing functions and all, those videos will help you to solve. Actually, wavy curve is required in each and every numerical that comes, any complicated numerical that comes in JEE Mains and Advanced. So do watch my video. I will give it in the description, or you can search it in my page. Do subscribe to our channel, students. So this is x, so this will be what? X plus 2 into x minus 1 is greater than 0. Students, so this is f dash x is greater than 0. So this is what you are getting, x plus 2 into x minus 1 is greater than 0. Now I will plot it on the number line. So basically this is minus 2, this is 1, and all the power is odd. So every time it will shift side. So this is plus, this is minus, and this is plus. Now basically this is the wavy curve. Remove this f dash x greater than 0. If you want to flow, basically this is the positive part, you will take the greater than 0. If f dash x is less than 0, you will have to take what, students? You will have to take the negative part. I think this is clear. F dash x is greater than 0, positive part. F dash x is less than 0, you will have to take the negative part. So the function strictly increasing the function is strictly increasing. Where, students? The function is increasing in minus infinity till minus 2, union 1 till infinity. Union 1 till infinity. The positive part plus means increasing, and similarly if you do f dash x is less than 0, here what you will have to take? You will have to take the negative part. So the function is decreasing in minus 2 to 1. So this is the part where it is decreasing, and this is the answer for increasing. So the function is increasing at minus infinity to minus 2, union 1 till infinity, and the function is decreasing between minus 2 to 1. Students, if you have any doubt in this, you can just quickly go to the comment section and ask me. So you can see the function of interval of decrease as well as increase. Minus 2 to 1 is the function decreasing in the interval, and increases when x is less than minus 2 or x is greater than 1. I think this was clear to you all, students. Let us see another important type of numerical that comes in joint entrance examination. This numerical that I am going to tell you has a very important concept which you will have to keep in mind. I'll give you the theorem, the formula first. Then maybe you can understand what it is. Say for example, students, always keep this in mind. If you have not studied integration, if you have not studied differentiation, still you note it down somewhere in a notebook so that you can come back when you're revising these chapters, you can remember that, students. So students, if it is given x, integration from a to x, gt dt, if this is given, say for example, when it is given, this is equal to fx. If fx is equal to integration from a to x, gt dt, f dash x, students, two important formulas I am giving you. F dash x is simply t is replaced by x, g of x. Simple. The function will be replaced by g of x. This t will be replaced by x. That's it. That is f dash x. I'll give you the proof when we are dealing with this chapter actually, but now you keep this in mind. So this is one important formula, and actually it is into, so this gx, this entire function is multiplied with the differentiation of x, that is 1, so we are not writing it, right, students? So this brings me, the second point that I said, this brings me to another formula. Say fx, say for example fx, so should I write fx? Yeah, say for example fx is equal to integration a till phi x gt dt. So this is the second formula. This was the first one and this is the second one. So if fx is equal to a till phi x gt dt, so f dash x, just now I told you, simply this part goes and replaces this t. So this becomes g of phi of x. Basically this function will replace everything, the t in this equation what you will be given, into this will be multiplied by the differentiation of this function phi dash x. So this is the formula. It will be multiplied with phi dash x. Here it is being differentiation of this function. The differentiation of x was 1. So basically you had 1 over here, hence we had not written it. So I think this is very much clear to you all. So this is the second formula which you need to use when some kind of increasing and decreasing function comes. So these are two very important formulas. We will quickly see one example where we will apply these formula and see what you will get. So application is very simple if you simply remember what it is. Students, more we will be studying in application of derivative integral chapters. So now I am parking it, but you should keep these two formulas noted in your textbook because these are very, very important formulas for JEE advanced examination. Students, now let us see one numerical. So the question remains the same. The question remains, hope you have noted it. If you have not, pause the video, note it down, and then you can move ahead, students. So say for example, you get a question, find the interval of increase or decrease for a function fx. Integration minus 1 till x t square plus 2t, t square plus 2t. So see, it is the same, you can understand it is hinting towards the same question dt, right? So find the interval of increase or decrease of the function, this one, students, right? So now you need to understand over here, Now you need to understand, you have to find what f dash x. You have to find f dash x. So what I told you, that this t, this is basically ft. This is a function in t, not ft gt. G of t, this is a function in t. So simply t will be replaced by this function that is given over here, that is x. That is simple. So replace t with x. If this would have been x square, then t would have been replaced by x square, the second function, and then multiplied by x square's differentiation, that is 2x. But now it is being multiplied with the differentiation of x, that is 1. But we have to remove this t with, replace this t with x. So x square plus 2x into x square minus 1. That's it, students. That's it. Simply the application of first formula. This is f dash x. Now you have to find f dash x is greater than 0. So simply what you will do is x square plus 2x. Take x common from here. I'll just remove it. X common from here. So x plus 2 into x minus 1 into x plus 1. X square minus 1. A minus b into a plus b is greater than 0. Right, students? So what are the critical points over here? So the critical points I can see is minus 2, minus 1, 0 and 1. So these are the critical points of this wavy curve, students. Again, all the power is odd. So again and again it will change sides. So simply like this, this will be the wavy curve. This is plus, minus, plus, minus, plus. That's it, student. Plus, minus, plus, minus, plus. Where seeing this you can easily say, seeing this you can these are the critical points. CP, critical points. We have already seen this in your wavy curve chapter, and you can see in every video which I am making, I am applying this wavy curve method, so you can understand how important this critical point, this wavy curve method is. Do watch the 2 videos. So basically now you can see where this is the function increasing. So I'm just writing it over. Increasing means the plus part. So minus infinity till minus 2, minus infinity till minus 2 union minus 1 till 0, union minus 1 till 0, union 1 till infinity. Right, students? Union 1 till infinity. Where is it decreasing? So decreasing means the minus part. So minus 2 to minus 1, union 0 till 1. Union 0 till 1. Students, do you have any doubt in this? Do you have any doubt in this? So the interval minus 2 to minus 1, union 0 to 1, the function is decreasing, and increasing in the interval minus infinity to minus 2, union minus 1 till 0, union 1 till infinity. Students, I think this was it about the video about monotonic function till now. This was the basic of monotonic function. When we go ahead, we learn differentiation, integration, and then we apply, then we will be learning more this into more depth. But since this much was required for the functions chapter to move ahead, so I think you are clear with this. If you like the video, do subscribe to our channel. Thank you so much for your time, students.